Houston, say again, please.
Houston, we've had a problem. We've had a main beam plus undervolt.
The plan was to finalize the floor assembly, but I got problems with the torque boxes. I'm going to remove these braces and the torque boxes to get at it. As a result, it affords me an opportunity to strengthen this key area. Stick around and see how it all turns out. Picking up where we left off, you'll recall from the last video, the back half of the floor assembly and all the DSC Quadrolink components came together. All I had left to do was weld the back half of the trunk pan into place. Well, here it is. I'm stoked. Everything turned out pretty sweet. Two things. One, bless his heart, Roger, Mr. Fireman, implanted in my brain the reality that there is no coating in behind that key structural area. So do I address it? Prep them properly. After all that horsepower gets transferred into this location. Well, I wasn't going to, okay? Here's the issue. Look at this. The fit between the torque box and the floor is poor, both sides. Here, we'll show you the difference. This is the factory floor with the torque box. Very nice tolerance. Here's the driver's side. It's not the worst of the two. If it was both sides like this, again, I probably wouldn't bother. And the passenger side. Yeah, I can get my finger in there. That's not cool. What I do like about removing the torque boxes, similar to what I did in the trunk area. I removed the skin, as I'm fond of calling it, floor pan, off those structural components because it affords me some flexibility to do things a little differently. So if I spin the floor assembly on my rotisserie and show you underneath, you can see here the torque box butting up against the frame rail flange, bottom on the sides and the top. Very nice tolerance. I have it fitting well. Once I disassemble this, to ensure that everything's in the right location, I'm going to drill a couple pilot holes on either side of the frame rail flange up through the torque box so that I know when it's separated, that torque box is exactly where it needs to be. In order to work the slop in the floor pan connection to the torque box, I'll need access to that corner of the floor pan. Back on top, you can see here this heavy gauge steel brace limits my ability to access that lower corner of the floor pan. So this brace will have to come off as well. So similar to the torque box, I'm going to drill a couple pilot holes through the brace, through the floor, so I know exactly how to relocate this. Okay, all done. Just about to pop the top brace off. Just to recap what I do, I take an 1/8 inch bit, I drill a hole through the top portion of the metal I'm separating over the spot weld so that the pin of my spot weld cutter sits firmly and doesn't skip all over the place. I dip the cutter in some Tap Magic, penetrate through the first layer. Once I break through, I stop, and then I use this skinny little pry bar, it's a tiny one, and just get underneath and make sure it pops up, and then move on to the next one. So here everything's on, and pop it up. So nicely coated on the inside, and only a couple bare spots of metal where it came together. Well, you can see a light haze of rust starting, so I get to clean this all up. Now I can move on to the torque box. I am going to drill down from the top through those spot welds and repeat. Okay, I got the floor standing up. Been working on drilling out these plug welds. Most of them I could get from the top, a couple from the bottom, but here it is. Yeah, so you can see that's the penetration of the weld for the seat anchor coming through, not prepped, and the back side with all the holes drilled. So now I'm going to be able to prep this. Let's pop the torque box down on the frame rail. Okay, here we have a bit of an x-ray view. The skin is off. You see the upper link pocket, the heavy-duty spring perch doubler plate, and here's the torque box. So you see how everything ties together. If we take the doubler plate off, here you see how the torque box relates to the frame. So you see what actually bears on the frame rail of this pocket. So this flange for sure, this flange whether we catch it or not, but you're welding on the inside along that frame edge. So you're set on that side of the frame rail. Here you plug weld through the frame rail, and this is all on sheet metal. So I am going to double up or box the frame in this location in a couple spots, and maybe even put a heavier gauge plate inset within the flanges so that this has something substantial to tie into, and similarly here with the torque box. Okay, first step, deal with the torque box. Okay, I have it clecoed down into my reference points, triangulated those 3 points, bang on, 1/8 inch hole, and my connection through the bottom up into the thing. Again, we maintain that tight, solid tolerance. We're good to go. Okay, so heavy gauge torque box, heavy gauge frame rail, doubled up here. What connects in as part of the overall assembly, subframe connector. Subframe connector comes through the floor here and will butt up against the torque box and tie into the frame rail. Am I concerned with weaving in a piece here, or that face connection here will be sufficient? Okay, so this is what I've decided to do. I've cut some plates out of 1/8 inch steel, prepped them, shaped them, and it's fitting to my liking. So on this side, you can see I've also drilled through the side of the frame weld because I'm going to plug through the frame rail to this reinforcing plate. Because my frame rail is accessible, I can tack weld along this existing reinforcing connection within the frame rail, inside, outside, and then similarly, that angled flange I can weld on the outside. Okay, both sides. The plate that goes on the inside, because of this embossed area, I've channeled around it. Fits down inside, fits around the channel, and again projects out. Okay, so with those two flanges sticking out, I'm going to put the torque box on. So all those plates in essence do are extend the frame rail out towards the front of the vehicle. They're tied in, plug weld and tack weld all along on the inside, and then I can also tack weld it to the torque box, both sides, and then I'll use the similar heavy plate and I'll plug the opening and weld it around. Okay, I've welded on the extension plates. Inside, the outer flanges, and plug weld through the outside face of the frame rail. Okay, now I'm ready to box the frame rail. I'm going to box it in 3 locations. I'm going to plug the opening at the flange and bridge the gap at the back of the torque box and the front of the upper link pocket, this area here. So I set a piece in place, and I'm going to weld through the frame rail on both sides. I've channeled the bottom so that any moisture that gets in there can still escape, but I'm going to box the frame in that location, and then up here in this location, and then I'm going to put a heavy gauge steel plate on in between. Okay, I've boxed the frame rail, the 3 locations again, in front, here, and here, so I can capture that floating part of the upper link box. I'm going to take the upper link box off, take the torque box off, and show you. Okay, front plate tacked down, captured, plug weld along the frame rail, down, and a few spot welds on either side. So I have that area boxed. Now I'm going to put a plate spanning the two to pick up that location. Okay, I've popped the torque box back on the floor pan, clecoed it in place. You see here the opening in the torque box, so I can slide the torque box up against the frame rail flanges. Here's where it gets plug weld flush to the frame rail. The frame rail comes back this way. But you see how the floor pan is offset from the torque box. The only place the torque box comes in contact with the floor along that bottom corner, or this bottom radius of the floor pan, is right along here. And that's why, in terms of that poor fit of the torque box on the other side, where I could get my finger in here, you know, there's only this limited area where the torque box actually is assembled against the floor pan, providing that structural rigidity or brace, and it was floating. Okay, this is the key contact point because everywhere else it's offset. Okay, the other reason I popped this back on because I have to transfer this opening from the torque box to the floor pan so I can slide the floor pan into position across those steel plates because I'm welding the torque box on first to the frame rails, and then I'll bring the floor into place. So I have to create an opening so I can get the floor on both sides. Okay, I'm going to show you a couple things here. You can see I've traced the underside of the frame rail because I'm going to prep that, drill my holes for spot welds, but I've also worked the slop in the floor pan. This is where I could stick my finger in. The fit along here and here was terrible. So I've resolved that. Just simply change the radius here and here a little bit, and a little bit of hammer forming on the floor pan face, and it's fitting marvelously. Next step in the process complete. Torque boxes are all welded on, welded seam around those flanges, through the torque box to the frame rail plate, plugged weld down to the frame, boxed out at the upper link pocket, all good to go, ready to slide the floor pan on and secure the floor assembly. The floor pan is slid back on over the frame rail extension plates, and everything is back where it should be. So why extend the frame rails? Plain and simple, it's an opportunity to create a more rigid connection between the rear frame rails and the Detroit Speed Subframe Connector. Why? Well, as designed, the subframe connector on the bottom extends to the frame rail, but at the top surface, it's only designed to weld to the floor pan, the lighter gauge steel of the floor pan. There's that gap at this top edge. Okay, so these plates in essence are a spline that I can feed into the subframe connector. I can weld down to it, and by introducing, or I intend to introduce another plate here that then I can weld the floor pan to, similarly to what I did here with the torque box, welding it to the flanges of the rear frame rail. I can weld the floor pan to the plate of this boxed in section. I'll box these flanges in yet one more time. That'll create and spread that load here and allow me to weld the Detroit Speed Subframe Connector to a rigid connection on the top, feed those through and weld through the sides plus underneath, really enhancing the rigidity and continuing that structure right to the connection of the front subframe. Next step is to cut more 1/8 inch plate to create this box section. I'm going to notch the extension plates from the top midway down. You see I've scribed the profile of the floor pan against those plates, and that backing flange I'll slot from the bottom up and then slide the two together and weld the joints. That'll give me the backing in the right location, both sides. Then I can slide the floor pan on one last time and begin to weld everything together. In terms of the cross or the subframe connectors, these plates as designed right now are on the large size, but it gives me the flexibility once I start to install the subframe connectors to cut back and shape these as required. So right now it's providing me enough flexibility. I'm not going to worry about the subframe connectors right now. I'm going to finish this backing plate, get everything in the right location, marry the floor back, and reunite the floor pan to the back half of the trunk pan and the new frame rails and the torque boxes and the like, and have a completed floor assembly.